Okay, good day everyone. So today is an asynchronous class. So this will be your topic for this morning or for this day. So it is just a continuation of our topic about water flow in pipes. So again, I would like to define what is pipes. So pipes daw is a tubular section or a hollow cylinder. So usually, but not necessarily na circular section siya. So it is used to convey substance which can flow. So sa atin pa, ang ating pipes daw, it's not necessary na ang kanyang figure or ang kanyang uh, section would be a circular. Okay? It doesn't matter kung circular or rectangular ang kanyang magiging section as long as nagko-convey siya ng water from one point to another point. Okay? So, ang pipes daw natin comes discussion of your fluid mechanics. So, nagsistudy siya ng motion ng steady flow and ng turbulent flow. So, last time, I have discussed the different types of major head losses. Major head losses that caused by the pipes and our substance. Okay? So, ano ba yung ibig sabihin ng head loss again? Diba? We defined last time that the meaning of the head loss is it is the total energy dissipated because of the because of the friction. Yun yung ibig sabihin ng head loss. Kasi 'di ba, once na if it is our pipe and it is at pumasok yung substance natin sa pipe, nagkikis-kis yung dalawang material. Okay? So, ibig sabihin, if nagkikis-kis sila, there is friction. Okay? When there is friction daw, sabi ng hydraulics or ng water pipes natin, there is head loss. Okay? If there is head loss, there is energy dissipated. Ano ba ibig sabihin ng energy dissipated? May nawawala na energy. Kasi nga, bumabangga or kumikis-kis yung dalawang material natin. Okay? So again, ano ba yung head loss, no? So it is caused by the velocity of the flowing water and the roughness of the pipe. So nagdedepende kung gaano kalakas, no, yung speed ng ating tubig and then yung roughness ng ating pipe. Doon natin siya nakukuha. So major losses are due to friction and they can be calculated using the following formulas. So you have first, no, na pinakilala ko sa inyo, you have your Darcy-Weisbach, you have your Mannings, you have your Hazen-Williams, and you have this definition. Your HF or HL, usually, no, kung meron kayong book, ang nakikita nyo is, aside from being HF, ginagamit natin is HL. So, the same lang yan. The same meaning, it is the head loss. Okay, so you have your F here as your friction factor, your L, that would be the length of the pipe, your V, that would be the velocity, D is the diameter, and G is the gravity. And for this one, your Q, that is the discharge or your rate of flow. Diba? Rate of flow or oh yeah, that would be rate of flow, but in terms of volume with respect to time. Therefore, that would be cubic meters per second. Kasi nagdedepende no yung depende yung nilalabas ng fluid natin sa laki also ng volume ng pipe natin or ng ating object. Okay? Depende siya with respect to time. So you have your Manning's formula, you have your N, no? It is called as your coefficient of roughness or roughness coefficient. So you have your R here. This is your hydraulic radius, where R is equals to A over P. Your A, that would be the area of the section. Your P, that would be the wetted perimeter. Yung basa lang, no? Yung basa lang. Wetted perimeter. Your S, that would be the slope of your hydraulic gradient. And for Hazen-Williams, now you have this formula, and your D, that would be the diameter. Your C, that would be the coefficient for your Hazen-Williams. Okay? So last time we have discussed the head losses based on formula based lang tayo. Given that you have uh, velocity, given that you have your discharge, given that you have your diameter, hinahanap natin, given diameter, hinahanap natin yung, ang tawag yan, hinahanap natin yung head losses based on the given situation. So what if, let us try to find your discharge, your velocity, your head loss, given that it is a worded problem na meron na tayong figure na binabasihan, no? Meron na tayong situation, parang ganun, no? So let us try to solve this one. Madali na naman tayo matatapos. We have 5 slides lang for today. No, additional example lang na kapag in-apply natin siya, ito ay situational problem. Okay? So let us try. So last time nagets nyo na no kung paano nyo ito nakuha, and then if you really did watch the video, no, and na-answeran ninyo yung questions ko doon, you will be enjoying a +2 either sa quiz or sa exam. I don't know saan doon. Basta yung mga tao or yung mga students, tao yun, yung mga students na nakapag-answer within the day na pinasa ko yung link at nag-answer sila ng value for your, I think that is discharge, no? So they will be enjoying +2 sa exam or sa quiz. So I may announce that one soon. So for this time, no, I believe na alam niyo na kung paano gamitin itong formulas na nakikita niyo ngayon. So let us try to apply that one in a situational problem. Okay? Again, ito pa pala, meron tayo, balikan natin. So you have your S here, your slope of hydraulic gradient. It is the head loss per length. So it is it is the head loss divided by the length. Ganon natin makukuha yung hydraulic slope natin, hydraulic gradient slope natin. So let us try to have this problem. Sabi niya, a pipeline system from a reservoir is designed for refilling trucks. So the 250 millimeter line or 250 millimeter diameter, it should be diameter. A 250 millimeter diameter line has an overall length of 30 meters. The 150 line is 350 meters. So this 150 is also a diameter. 3-meter long discharging at point A, while at the one is discharging at point B, which is 15 meters long. So sa atin pa, meron tayong tatlong pipes. Okay? First, sabi niya you have a 250 millimeter diameter pipe na ang haba niya would be 30 meters, which is her length. Its length, okay? The other one, for your point A, nagdi-discharge do tayo at point A, having a diameter of 150 millimeter diameter, and it is 3 meters long. For point B, for your third pipe, okay, you have a 150 millimeter diameter pipe as well, but the length would be 15 meters long. So considering that this tree has a friction factor of 0.020. So kung friction factor tayo, ibig sabihin anong formula ang gagamitin natin? That would be your Darcy baseback. Okay, kasi yung Darcy baseback lang naman yung merong friction factor na formula among the three. Tama? So let us try to find or determine the following. So compute the discharge flowing through 250 mm diameter pipe. Compute the discharge flowing from 150 mm diameter pipe at point A. And compute the flowing through discharge at pipe through point B. This should be point B. Okay? Point B dapat yan. Okay. So, let us try to figure it out, no, based sa problem. Let us try to imagine kung ano ba yung sinasabi niya. Okay? So sabi niya, meron na kayong reservoir. Okay? So the elevation of your reservoir is 24 meters. Okay? So meron din tayong trunk. So yung tubig na galing sa reservoir, no, kukuha tayo ng tubig galing sa reservoir para ilagay natin mismo sa ating truck. So with that, meron tayong uh, pipe, no, na nakakonect sa ating reservoir, which 250 millimeter diameter, and you have your point A na nag-discharge sa truck na meron tayong 150 mm diameter, and you have another pipe na nag-discharge also or nagbibigay also ng tubig sa inyong truck with point B. Okay? So, ibig sabihin, we have considering 3 discharges. Okay? The first discharge is your 250 millimeter diameter pipe. Okay? Bakit siya nagko-consider as Q1? Kasi 'di ba kumukuha siya ng tubig galing sa reservoir. Okay? Ibig sabihin, nagdi-discharge siya ng tubig. Tama? Next discharge, you have your Q2. Okay? Yung Q2. So yung Q2 yan, nag-discharge siya ng tubig from point A papunta sa truck. Ibig sabihin yung tubig na nanggaling sa point 1 ninyo, ito sa 250 millimeter diameter, pumapasok siya sa ating pipe A and then dinidistribute niya ang water papunta sa truck. Okay? That is considered as your discharge 2. Tama? You have your discharge 3 considering that this is your pipe 1, no? Pipe 1, pumapasok na naman yung tubig sa point B ninyo and then dinidischarge niya ang tubig. Okay? That is considered as discharge 3. Kasi imagine niyo kung wala, i-imagine niyo kung wala yung ating Q1, meron ba tayong madi-discharge sa Q2 at Q3? Di ba wala? Tama? Again, kung walang tubig na nagfo-flow sa ating pipe 1, meron ba tayong tubig na nadi-discharge sa ating point A at point B? 'Di ba? Wala. So sa madaling salita, lahat ng tubig na nadi-discharge sa inyong Q2 at Q3 is nanggagaling sa Q1. So tama bang sabihin natin that Q1 is equals to Q2 plus Q3? Tama, 'di ba? Kasi yun na nga, nagets na nga natin that yung tubig na nanggagaling sa point A ninyo at yung tubig na nanggagaling sa point B ninyo is nanggagaling sa Q1. Okay? Therefore, you can conclude no that the flow coming from your Q1 is equal to Q2 plus Q3. Okay? Sige nga, for example, answeran nyo kahit di ko ka naririnig. Okay lang yan. I believe pinapanood nyo naman ng maayos. For example, you have your Q1 and you have your connecting pipes na nagdi-distribute din ng tubig para sa inyong truck. No? So you have your Q2, Q3, Q4, Q5. So what will be the equation of that? Ano yung magiging equation niya dyan? Di ba magiging Q1 is equals to Q2 plus Q3 plus Q4 and plus Q5. So imagine nyo kung wala yung Q1, kung wala yung discharge at 1 natin, discharge at point 1, therefore walang madi-discharge sa Q2, walang madi-discharge sa Q3, sa Q4 as well as sa Q5. Okay? So, ibig sabihin, the total discharge of your Q2, Q3, at Q4, at Q5 is coming from the discharge 1, which is your Q1. Okay? Intindihan? Very good. So, hahanapin daw natin yung discharge at 250 mm diameter pipe. To, hahanapin daw yan natin, which is considered as your Q1. Okay? So, ano pa ba? So, sabi dito, no, makukuha natin yung ating discharges with the use of your head loss. Ano yung clue niya na yun yung gagamitin natin? Kasi, nagbigay siya ng friction factor. But first, let us try to get the head loss, the total head loss. Okay? So, you have your total head loss as 24 minus 6. It is the difference between the elevation, between the height elevation of the water coming from your reservoir, okay, papunta sa point A at point B ninyo. No? So kung pumapasok ang tubig dyan, there is an energy dissipation. Okay? So that is your total head loss. Okay? Total head loss para sa lahat. That would be the difference between the elevation of the water of the reservoir papunta sa point kung saan nandoon yung inyong pipe A and pipe B. Okay? So therefore, your head loss, that would be 18 meters head loss from your reservoir to point A. Okay? So ano ba yung formula natin sa head loss? Since we have your friction factor, therefore we will use Darcy-Weisbach formula. So you have 0.0826 FLQ squared D raised to 5. It is very easy, no? Topic, basta alam mo lang yung flow of your water and alam mo lang, memorize mo lang yung formula. Doon na naman tayo magtatalo, no? Kung paano nyo memorizein yung formulas. Pero kaya nyo yan. I believe, no? Kaya nyo yan. So, move on. Let us try to continue. Yan. So, this is our figure. So, sabi natin kanina, according, no, that your discharge 1 is equals to Q2 plus Q3. So, let us try to find the head loss from your reservoir to point A. So, di ba sabi natin kanina, you have your total head loss coming from no, coming from the elevation of your reservoir papunta sa point A. So that would be your total head loss pa lang. Okay? So 'di ba kapag once na pumasok yung tubig sa ating pipe, there is an energy dissipation also. Okay? So that is considered as your HL1. Okay? So kapag ang tubig pumasok sa pipe A natin or sa pipeline A natin, 'di ba there is also another head loss. Tama? So that is considered as your HL2. So magkaiba yung head loss natin sa HL1 at sa head loss natin sa HL2 kasi magkaiba sila ng pipe. Nagkakaiba sila sa diameter or sa cross-section ng pipe ninyo. Okay? Therefore, you have your HL, your total head loss, no, from your reservoir to point A and B, and you have your head loss for your pipe 1 and you have your head loss for your pipe 2. Okay, I hope na gets yan. So, you have 18 is equals to 0.0826 F times 30 times Q1 squared divided by 0.25. So, saan nang galing yung L? Diba it is stated sa problem na meron siyang 250 mm diameter and meron siyang length na 30 meters. Ibig sabihin itong pipe po natin 30 meter diameter daw siya. For your AHL2, same formula, you have 0.0826 F times 3. So, ibig sabihin, 3 meters daw yung pipe A natin. Okay? Divided by 0.15 raised to 5 since yung ating pipe is considered as 150 millimeter diameter. Okay? So let us simplify. So we have one equation but two unknowns. Bakit siya nagkakaroon ng two unknowns? You have your Q1 and you have your Q2. So gagamitin natin itong main equation natin para makuha natin yung discharge at 1. Yun yung first main goal natin, di ba? Is to get the value of your Q1. So pwede mo natin gawin na isolve natin yung value of your Q2 in terms of Q1 para kung nakuha natin yung equation in terms of Q2 ninyo, ipasok natin dito siya sa equation natin. I think pwede siya, di ba? Pwede? Algebra way, pwede siya, di ba? So, sige, before that, let's us try to simplify first the equation, no? In terms of Q2. Okay? So, kindly simplify this term. No, wag niyong isali yung Q1. So, I believe your F, that would be 0.020. So, sige, pakisolve. Iwan nyo lang yung Q1. Wala yung pakialam kasi variable siya. Sige nga. And then the other thing also, for your Q2, no, pakisolve to. Ito lang alone. Simplify natin in terms of Q2. I'll give 2 minutes, no? Sige, 2 minutes. Okay? So, let us try to figure it out. So, tama ba na ang nakuha nyo is 50.75 Q1 squared? Okay? So, you also have 65.26 Q2 squared. Ayan, nasulat. Okay, so tama ba? Same time na nakuha. And then, next thing that we need to do is, di ba, in terms of Q2 tayo. So, dapat lahat ng values natin is nasa left side. Kasi Q2 nga tayo, di ba, kinukuha natin yung value ng Q2. But then again, meron tayong nakikitang whole number sa Q2. So, by doing your algebra, we will multiply both sides by 1 over 65.26 para makancel itong 65.26 natin sa inyong original equation. So, ibig sabihin, you have 18 divided by 65.26. You have 50.75 divided by 65.26 and 65.26 divided by 65.26. So, it will give you 0.276 is equal to 0.78 Q1 squared plus Q2 squared. So, pwede na tayo mag in terms of Q2. Okay, since wala nang sagabal, ano na yung gagawin natin? Ililipat na lang natin yung value ng Q1 ninyo on the other side of the equation. Okay? And then simplify, no, since it is square root, or I mean it is squared, so magiging square root yung ating equation. So you will be having a square root of 0.276 minus 0.781 squared. Therefore, this equation 1, no? Erase ko yung iba kasi magulo na. Hindi siya ma-erase. So, ibig sabihin, itong equation 1 na ito, no, for your Q2, pwede na natin siyang ipasok dito sa ating original equation, no, for the value of your Q2 para makuha natin ang Q1. So, ano na lang yung ano na lang yung kulang natin sa ating original equation to get the value of your Q1? That would be the value of your Q3 in terms of Q1. Okay? So, kukunin natin yan sunod. So, let us try to have the head loss from your reservoir to point B. So, same sa sinabi ko kanina, di ba? That your head loss, your total head loss, it is coming from the reservoir papunta sa point A at point B ninyo. Okay? So, if you have your head loss at your HL1 or your first pipe, yan yung magiging head loss nyo. That is why you have your HL1 pa din. And then, the second head loss would be the head loss coming from your pipeline B. Okay? Another head loss, it's because it is different cross section. It is 150 mm diameter pipe. Okay, and I think the length of that one is 15 meters according sa problem. Okay, so you will have 18 is equals to 0.8026 F30 Q1 squared. And then for HL2, you have this equation again. So, same procedure na ginawa natin sa inyong Q2 kanina. So, we will simplify the equation. So, ito, HL1 natin, na-solve natin kanina. So, this is 50.75. Okay? Q1 squared. So, ano na lang isi-simplify ninyo? Ito na lang, head loss for your Q3. Sige nga, pakisolve. Okay, so that would be 18 is equals to 50.75 Q1 squared plus 326.32 times Q3 squared. So we will simplify the equation para mag Q3 tayo in terms of Q1 para yung value ng Q3 mapasok natin sa original equation natin. Okay? So, ano yung gagawin natin? The same kanina sa ginawa natin. So, that would be, hindi ko makita, that would be multiply both sides by 1 over 3 to 6.32 para makancel natin to. Okay? This will be cancelled, that would be cancelled. So, 18 divided by 3 to 6.32. So, you have 50.75 divided by 3 to 6.32. So it will give you 0.055 is equals to 0.16 Q1 squared plus Q3 squared. So in terms of Q3 tayo, so ililipat natin yung value ng 0.16 Q1 squared on the other side of the equation. Okay? So that will give us, wait lang. And then square root natin no kasi naka-squared. Alam niyo na yan. So it will give us an equation of square root of 0.055 minus 0.16 Q1 squared. So that will be your equation number 2. Okay, so therefore we can conclude that we can solve for the value of your Q1. So diba kanina sabi natin we have mentioned that Q1 is equal to the discharge of your Q2 plus the discharge of your Q3. So for in this case, you have your equation 1 in terms of Q1 which is square root of 0.2 ito. Square root of 0.276 minus 0.78 Q1 squared. At yung Q3 natin, check na rin kasi meron tayong equation number 2 which is 0.055 minus 0.16 Q1 squared. Therefore, kung pinagsama-sama niyong lahat, magiging ganito yung equation natin. Tama ba? Tama? So, this equation comes from Q2. So, this equation comes from Q3, no? Due to their head losses. So, in this case, or in this manner, we are able to get the value of your Q1. Sige nga, 2 minutes, can this solve for the value of your Q1? Okay? So sige, paki-confirm if the value of your Q1, that would be 0.466 cubic meters per second. Okay. Okay. Sige, very good. I think we have the same answer now. So how about for your Q2 and Q3? 'Di ba hahanapin natin based on the question, hahanapin daw natin yung discharge at 150 mm diameter at point A at hanapin natin yung discharge at 150 mm diameter at point B. So sige nga, any idea kahit di ko kayo naririnig, can you answer? No, kahit di ko kayo nakikitang can you answer me? No? Kung ano yung gagawin natin, the easiest way for us to solve the value of your Q2 and Q3. Ano kaya? Siret? So, siret ba? So, sige. I think may naririnig ako na tama na answer. Charot. I think your idea is correct. No, since we are I think mali. Since we got the value of your Q1 or your discharge at 1, therefore we can conclude that you can use the value or the equation of your Q1, I mean the equation 1 and the equation 2 to get the values of your Q2 and Q3. Kasi ano lang ba yung kulang natin sa equation Q2? That would be your Q1. So since meron na tayong 0.466 na value for your Q1 or discharge at 1, so pwede na nating makuha yung value ng Q2. Tama? The same as well, no? Sa Q3 ninyo, so ano bang naghaharang, ano bang balakid natin para makuha yung discharge at 3 natin? Di ba yung discharge at 1? So since na-solve na natin yon as 0.466, therefore we are able to get the value of your discharge at 3. Okay? So kindly solve for the values. Is it correct that your Q2, no, that would be square root of 0.276 minus 0.78, and this one is 0.466. So I guess that is correct, 0.327 cubic meters per second. And for your Q3, no, that would be 0.139 cubic meters per second. Okay? I hope na-gets natin, no, kung ano yung nangyari. Okay? So, kapag gumagawa kayo ng equation, kasi 'di ba the first step na ginawa natin, 'di ba, the very first step that we made make kanina is gumawa tayo ng original equation natin, which is our original equation is your Q1 is equals to Q2 plus Q3. So ano yung kailangan niyong tandaan, no, kapag gumagawa kayo ng equation? Isipin nyo or i-imagine nyo kung saan ba talaga nanggagaling yung tubig. Kung sino ba yung distributor ng tubig. Parang gano'n lang. Kung saan nakaka-connect lahat ng pipe natin to distribute the water. Kung ano yung main pipe natin. And with that main pipe, no, makakaroon kayo or makakagawa kayo ng equation ninyo. Okay, through that equation, you can use the head losses, formulas, and you are able to get what is asked in the problem. Okay? So let us continue for your the second and last example for this discussion. So you have points A and points B are 5 kilometer apart along the new cast iron 60 centimeter on a pipe carrying water. So point A is 9 meters higher than B, and if the pressure at B is 140 kPa greater than A. So ibig sabihin mas malaki daw yung pressure at B. So determine the following. So the head loss, the direction of flow, and the amount of flow. Your amount of flow asking for your that is asking for your discharge, no? Rate of flow, so yung direction natin kung pataas ba or pababa yung ating tubig, and the head loss, the energy dissipated at the said flow. Okay, so let us have your figure. So sabi niya, no, your point A and point B daw is 9, your point A, ibig sabihin naka-tilted yung pipe natin. Your point A is 9 meter higher than your point B. Okay? Point A, point B. That is their vertical distance of the two. And then, sabi niya, point A and point B is 5 kilometers apart. Okay? Magkaiba yun. So, point A is high. higher than point B by 9 meters, and then the distance between the two along the body, that would be 5 kilometers. Okay? So ano lang ba yung binigay na section? That would be the section of the pipe lang. Itong section na pipe na ito. So since nakita ninyo sa ating pipe that you have two different pipes, tama? Wait lang ha, hindi ko makita yung ating sulat-sulat. Ay naka. No? So you have here your point A, you have here your point B. Okay? So as you can see, nagkakaroon tayo ng different types of pipe. Kasi 'di ba you have a bigger pipe and you have a smaller pipe. So according no sa ating definition last time sa water head losses ninyo is that you have a minor head loss if there is a difference between the enlargement of your pipe. Ibig sabihin, kapag ang malaki na pipe, i-connect mo sa maliit na pipe, uh, there is a consideration of minor head losses. Okay? But in this case, no, in this case, since yun na nga, nagkakaroon tayo ng different na diameter for your pipes, so we will use your Bernoulli's theorem or your Bernoulli's equation. So kailan ba natin ginagamit ang Bernoulli's equation? No, it is when the continuous steady flow, the total head at any point in a stream is equal to the head at any stream equal plus the head loss between the two points. So ano bang mas madaling definition nun? So, sa madaling salita, ginagamit natin yung Bernoulli equation natin. Kasi nga, it is related to dynamics, di ba? The movement of the water, di ba? Ang dynamics, it is all about the motion. Okay? So, it says that this concept daw is kapag ang substance is hindi napipiga when it passes from different types of pipe, yung different types of diameter, nagbabago yung tulin nito. Okay? Nagbabago, sa atin baba, nagbabago yung speed niya. Okay? Kapag yun nga, yung sinabi ko, di ba? Kapag bigger pipe, nagmahina yung magiging flow. Example na lang sa hose natin. Okay, sa mga hose natin. Pag hindi mo pinihit yung hose, ang flow ng tubig natin is okay lang, stable lang. Tama? But then again, once pinihit mo yung hose, kanang gipaggamayan mo iyang opening, di ba nakikita nyo yung tubig is nagrarapid siya ng flow. Tama? Okay? So that is considered as ginagamit natin yung theorem ng Bernoulli. Kasi nga from bigger opening, no, nagkaroon ng smaller opening. No, when that happens, nag-iiba yung speed ng ating anong tawag mo yan? Nag-iba yung speed ng ating fluid. Okay? Kaya gumagamit tayo ng Bernoulli equation. But then again, in this case, your point A and point B is talking about your large or your bigger diameter. No? So, a bigger diameter pipe, since ito lang yung property rin na binigay sa problem. Okay? Point A at top, point B at the bottom. Okay? Yung papasukan ng isa pang pipe. So, it is daw a 60 centimeter diameter pipe. So, given that you have your friction factor na 0.019, so ibig sabihin, Darcy waste back yung ating gagamitin. Okay? So, letter A. So, VA is equals to VB. The speed or the velocity at point A is the same as the speed at the velocity at point B. Kasi nga 'di ba, yun na yung sinabi ko kanina, they're on the same pipe. Marag sa to pa, point A that would be the top, point B that would be the bottom of your pipe. Okay? So ibig sabihin, kung ano yung speed na pumapasok sa ating point A, yun din yung speed na pumapasok sa point B. Saka lang magbabago yung speed kapag yung tubig is nakalagpas sa point B at pumunta na sa smaller pipe natin. Therefore, VA is equals to VB. Okay, parang sa motion natin, sa rectilinear motion natin, yung uniform, when acceleration is 0, your velocity is constant. Okay? Constant. So, since dito, sa ating first pipe, sa pipe 1 natin, no, sa pipe 1 natin, you have your point A and point B, there is no acceleration since walang pagbabago ng diameter for your point A and point B. Therefore, your velocity is constant. Sana naalala niyo yan sa rectilinear motion ninyo, yung first uh, uniform motion, when you're constant, constant. Where acceleration is 0, your velocity is constant. Okay? So, I believe that you remembered or you are familiar with the formula of your Bernoulli's theorem. So, you have your VA squared over 2G plus PA times unit weight of water times the elevation of A equals to VB squared divided by 2G plus PB times over the unit weight of water plus the elevation of B times the head loss. So since pinag-uusapan pa rin natin yung pagpasok ng substance sa pipe, therefore meron tayong head loss. Okay? So itong VA squared over 2G natin dito, tinatawag natin yung velocity head. Paki-take note, tinatawag natin yung velocity head. At ang PA over your unit weight density, tinatawag natin yung pressure head. Kasi what if, no, sa question natin, try to find the velocity head at point A. Try to find the velocity at the pressure head at point A. Ganyan. So, itong Z, that would be the elevation of your point A. Elevation. Okay? And then your HL, that would be your head loss. Okay, again, ginagamit natin yung Bernoulli equation ninyo when there is ang pagbabago sa inyong pipeline diameter. Kasi nag-iiba yung velocity ng ating tubig or yung speed ng ating tubig sa different types of diameter. Okay? The bigger, the slower the flow. The smaller the opening, the smaller the diameter, the faster the flow it has. Okay? So, since sinabi natin kanina at point A at point B ninyo is that, erase ko ha, nasulat nyo na, I believe nasulat nyo na lahat. Okay. So, sinabi natin kanina that the velocity at A is equal to velocity at B. Therefore, pwede na natin siyang i-cancel sa ating equation. Tama ba? Kasi kapag nilipat natin sa other side of the equation, itong VB squared over 2G, since this is equal, di ba, it will turn into a 0 lang pa rin. So, para hindi tayo mahirapan ng solve natin, i-eliminate lang na natin sila, ika-cancel natin sila. So, you're leaving PA divided by unit weight density plus ZA plus PB over unit weight density plus ZB plus unit head loss. So, based sa question natin for letter B, hinahanap natin yung, katinang ilong ko, yung direction of flow ng ating tubig. So, pwede tayong mag-assume na ang tubig natin is galing sa point A papunta sa point B, or pwede rin tayong mag-assume that our water is galing sa point B papunta sa point A. Pwede ganun, di ba? Hindi natin alam. Okay? So, in this type of solving, let us try to assume na lang muna. Okay man, okay. Paminsan-minsan okay din mag-assume, guys. Okay. Pwede din tayong mag-assume paminsan-minsan. Katitraga ng ilong ko, sorry. So, let us assume. Pwede tayong mag-assume basta sa worded problem lang, hindi lang sa relasyon. Charot. Let us assume that the flow is from A to B. Yan na lang ang ating assumption una, A to B. That ang tubig is pumapasok sa A, tapos dumadaan sa B. Okay, yan na lang yung ating assumption. Okay? So, you have PA times unit weight density plus 9. So, bakit ganun yung elevation? Diba, according to us, no, kanina, our assumption is ang tubig is galing sa A papunta sa 9. So, ano ba yung distance? No? Ano ba yung distance natin galing sa A papunta sa B? That would be 9. Okay? Is equals to PB plus the unit weight density plus 0. So, bakit siya 0? So, di ba lahat ng flow of water natin papunta from A to B? So, kung ang B pupunta sa B, ano bang elevation nun? That would be 0. Again, meron tayong 9 kasi ang flow of water galing sa A papunta sa B, that would be 9 meters. Ang distance papunta ng flow of water from B papunta sa B, that would be 0. Okay? Therefore, in this manner, we are able to get the value or the equation for your head loss. Diba? Makukuha niyo yung equation for your head loss kung ililipat nyo yung pressure head ng B on the other side of the equation. So, therefore, you will have PA minus PB divided by the unit weight density plus 9. No? Common denominator. Common denominator, itong nangyari dito. Algebra, common denominator, kaya naging ganito. So, kung ayaw nyo ng ganyan, pwede nyo pa rin siyang isulat, no? PA over unit weight density minus PB unit weight density plus 9. It is the same orientation pa din. Okay? So, continue. So, you have here, PB is equals to PA plus 140. Bakit meron tayong equation na ganito? That your pressure at B daw is PA plus 140. Take note, it is stated sa problem that your pressure B daw is mas malaki ng 140 sa inyong pressure A. Okay? That is why pressure A plus 140. Tama? So, yun yung ating tanong. Okay, continue. Okay, so let us continue. Since kanina, nakuha na natin yung equation for your head loss and the equation for your pressure at B. Okay? For us to enable to get the value of your head loss, kasi yun yung unang tanong, diba? Head loss, ito yung tinahanap natin. So, pwede ba nating ipasok yung value ng PB natin dito? Okay? Para yung value ng HL natin, ipasok natin dito. And then the value of your PB, ipasok natin ulit dito para lahat tayo is in terms of PA na. Nagets ba? So, magiging ganito yung equation natin. Okay? Parang algebra lang talaga yung nangyayari. Pinapasok nyo lang yung mga equation na pwede sa ating original equation. So, you have PA over 9.81, di ba? 9.81 since it is the unit weight density of water. Okay? Plus 9 is equal to PB. PB, ang value ng PB, that would be PA plus 140 divided by 9.81 plus 0, that would be the elevation at B, ZB natin, plus your head loss. Okay, erase ko yung iba para makita ninyo. Your head loss. Your head loss formula is PA minus PB over 9.81. So you have your PA minus PB. Ang value ng PB natin would be this one. Pasok natin dito. Diba? Divided by your unit weight density, or that would be 9.81 plus 0, plus 9 rather. Okay? So sige nga, 2 minutes, kindly solve for the value of your PA. Okay, I guess you will get an answer of 0. Okay? If you don't agree, pwede ninyong, kung hindi kinaniwala sa calculator ninyo, no, pwede nyo siyang manumanuhin and you will get pressure at A equal to 0. Therefore, pwede na ba natin makuha yung value ng head loss? Okay, pwede na. No? But first, let us try to compute the value of your PB. So therefore, your PB, that would be 0 plus 140, that would be equal to 140. So ano bang unit ng ating pressure? That would be kilopascal. This one is kPa. Okay, or kilonewton per meter squared. Okay, so let us try to solve for your head loss. That would be 0 minus 141 divided by 9.81 plus 9. That will give you a negative 5.27. Take note, there is no such thing as negative distance. No? Itong negative na mini nito, ibig sabihin, mali yung assumption natin kanina. If our assumption a while ago is ang flow of water galing sa galing sa A papunta sa B. So by solving your total head loss, ibig sabihin, the rate of flow na ninyo or the flow of your water is, the direction is from B to A. Ibig sabihin, yung flow ng tubig natin is pataas. Okay? Our assumption kanina is mali. So this negative is just an assumption or just a conclusion for your direction. Parang parehas ng good sa ating vectors or sa statics ninyo, yung negative that will be indicate that your force is downward. Okay? So in this case, mali yung assumption natin kanina. But then again, there is no such thing as negative distance. Okay? So let us try to solve for your rate of flow or the amount of flow given that your F is 0.019. So since you have your head loss, you have your friction factor, ang gagamitin natin is Darcy waist back. Okay, so you have HL is equals to 0.0826 FLQ squared D raised to 5. So you will have positive na ha, positive na. Kasi alam naman natin yung rate of flow natin, or I mean the direction of flow. That would be 5.27 is equals to 0.0826, 0.19, 5,000 Q squared, 0.60, 0.60 raised to 5. Okay? So that will give you a value of your discharge at 0.288 cubic meters per second. Okay? So I guess this ends our discussion for this morning, or discussion for this asynchronous class. So if you have any concern or clarification about the said topic, so don't hesitate to ask me. Okay, no hidden activity for now, no, kasi alam kong yan na yung babantayan nyo every video. So siguro secret lang, no? I'll decide kung kailan ko ako maglalagay ulit ng hidden activity in the video, no? For you to really watch the content of the video I am making. Kasi hindi rin madali gumawa ng ganito, no? Okay lang. So, yun. So, if you have any concern, clarification, kindly ask na lang sa GC natin. And I hope you learned something, no? For this morning and for this type of video. So, God bless everyone and see you next week.